Greetings, advanced do-it-yourselfers. So as promised, we will go over the electronic EGR valve, which will conclude this Diagnosis and Understanding series on EGR. I wanted to get this video out to complete the series before leaving on a business trip. Turns out I've got a little opportunity because my flight is delayed. So I'm really trying to squeeze this video out as quick as possible, hopefully do the editing on the airplane and get this thing out to you much quicker than promised in the last video. But before we start, I have to make two corrections. I made two rather egregious errors in the first part of the series, which was pointed out by a couple people. One of them, and really one, I don't understand how I missed this because it was a specific point I wanted to bring up, and that is on the purpose of the EGR valve. I forgot to mention the main purpose. I had mentioned, of course, about the cooler combustion temperatures that you get as a result of the EGR. I somehow completely whiffed on mentioning the result of this is lower nitrogen oxide emissions. So that is the main purpose of it, is to lower your NOx emissions as it would show up on an emissions report. And it's really egregious that I forgot about that, because the whole point of doing this series is I have a car coming in a couple weeks that I strongly suspect will have an EGR problem, because when you look at the data from his failed emissions, it's very clear because of the high NOx emissions that he has and the times that they're occurring, it's a pretty safe assumption that he has a stuck closed EGR. And I will show you that, but I somehow overlooked saying that in the last video, so my apologies. The second one, and thanks to, I think it was John Wrench that brought this up, I had a Ford in here for the Diagnosis and Understanding of the vacuum solenoid type EGR, and I completely whiffed on going over the DPFE. And that is totally a fault on my part. I didn't even think about it because I don't work with Fords that much. I'm not even really all that familiar with DPFE, although the testing for it would be pretty straightforward. I believe the car that I mentioned that's coming in, I think is a Ford. And if so, I will most certainly cover DPFE. But for those not familiar, DPFE is a EGR measurement that, to the best of my understanding, is used on Fords, which it just happens to be I don't see that many. Being a do-it-yourselfer, I don't get to choose a whole lot of the cars I see. But what does it stand for? It's got to be differential pressure for EGR, or differential, it would be differential feedback. No, differential pressure feedback for EGR, I think is what it would be. But anyway, the point of it, you can tell from the context there, that basically there's going to be, for all practical purposes, it's kind of like a map sensor that some EGR gas will go through that, and it's kind of like a two-tube map sensor, so that it measures the delta between the, with the EGR in one tube, and I believe probably atmospheric on the other. I'll have to look into that. But basically, it's sort of a measurement to tell flow of the EGR. And as I mentioned in part one, there are different methods for measuring the flow through the EGR. And in Fords, at least, this is one method. So my apologies, I completely whiffed on that, and we will cover that in another video. As you know, I do try to cover every variable and every possibility, so whatever you run into would be mentioned or covered. And I failed a little bit there, so we'll make up for it. But I still think it's a hell of a lot better than a 2-minute, 5-second video on how to just change an EGR and then ignore all the comments from people that say I changed my EGR, it didn't work, now what? So I still think I'm a step above that. Let's go ahead and look at an electronic EGR, and I think this will go quick because they're actually fairly simple. So this right here is a typical, this is a GM electronic EGR valve, a 5-wire EGR, as most of them are, so you will probably be very familiar with this in most of your vehicles made after 2000. And basically, the simplicity of this is that it substitutes the vacuum solenoid and all of that stuff, and basically the position of the EGR is just simply controlled directly by the computer. And we can see here you've got your input port for EGR and your output port. So this may bolt a little bit separately from the intake manifold than more of your traditional EGRs like that Ford one does. By the way, you may even notice something here. Do you notice something wrong here? And that is, if you look, the pintle on this EGR is open. This is a bad EGR valve. The pintle happens to be stuck open. What would the symptoms be for this car if that is the case, that the EGR is always stuck open? Based on the previous video, it should be very clear that this would be pretty much a no-start condition. The engine would most likely start and then die very, very quickly, if it even starts at all, or it would only run when you've got your foot pretty heavy on the accelerator pedal, and that is indeed the case. But basically, this pintle should, of course, be in the closed position, and we'll need to get a wiring diagram to look at our wires. But basically, what's going to happen is we're going to have a 12-volt power wire and then a ground wire for the actual movement of the pintle. And that leaves 3 other wires. One of them is going to be a 5-volt reference. One is going to be a reference sensor ground. And then the other one is going to be a signal wire. Now think about that for a second. 5-volt reference, signal wire, and ground. Where else have we seen this pattern before? So some of you probably are saying, well, the throttle position sensor in the TPS understanding and diagnosis video was very similar, and you would be exactly correct. It's actually identical. It is a potentiometer just like this is. Changes in the position of the device will change resistant, which has a variable effect on voltage, and the computer measures that voltage delta to determine a position. Some of you may also say, well, the fuel gauge, when I diagnosed the stuck empty fuel gauge, was also similar, and you would be correct. Again, same principle, a potentiometer. And that's why in the TPS video I said if you understand how to test and diagnose one potentiometer, you know how to do all of them. Some of you may also say the map sensor in a previous diagnosis and understanding video. It's not quite a potentiometer, but still, it is the same principle, a 3-wire map. Same type of thing. Deltas in pressure would have a delta in the resistance, same measurements. So we're not going to go over extraordinarily thoroughly how to do the measurements on this. I will cover it briefly because if you watch the TPS diagnosis and understanding video, you will know how to test the position sensing on this. So basically the strategy with an electronic EGR, you have 2 tests to do. You need to test the main electrical, the 12-volt in the ground, to make sure that the EGR valve does have pintle movement. And then separately, you'll want to test and verify that your position sensing works. And it's the exact same thing as testing a solenoid in the one way and as testing a potentiometer in the other way. So we'll go over that real quick. Probably not so much on this one because it's broken, but let's go over to my Trans Am, which uses the same valve, and I know that one works, and we can look at some ways to test it. So the primary objective today is for me not to get my nice clothes dirty, but I don't think that'll be an issue because this is going to be very simple since the EGR valve on LS1 engines is located right up there near the front all by its lonesome. So we can see we've got our 5-wire connector here. This one's got a little tab covering the wires, so it's hard to back probe them, but you can just remove that tab. I'll show that to you, and actually I've got another trick that I do that I'll show you. Obviously we've got a pipe right here that is going from the EGR valve to the intake manifold, you can clearly see. And then, of course, underneath the EGR, we have the pipe from the exhaust over there. So let's go ahead and get that. Let's see, what's a good way to do this? A good way to do this, first of all, especially if you're a beginner, the safest way would be to do EGR valve testing off the car. So let's go ahead and remove that thing and get it to a workbench, and we'll do some off-the-car tests. So let's get that connector off and then get the 2 bolts here. All right, and there we go. And it still kind of angers me a little bit that if that was all there was to this video, I would have 250,000 subscribers and all that, but you show somebody why they need to change this video and you end up on the bottom of the bucket. Isn't that sad? And of course, we want to always check our ports here to make sure there's no carbon clogs here, which there isn't. Of course, we would have a stuck closed EGR valve symptoms, as mentioned in the first video, if either or both of those were plugged with carbon, which is fairly common, as I've mentioned. All right, so I've got my bad EGR valve labeled there so I don't accidentally put the bad one back on my car. As you can see on the good EGR from my valve, the pintle is in closed position as it should be. as opposed to this one that's stuck open. And I probably could try to free that. And no, I did get it freed up at one point, but I did tell the owner that I was pretty confident that we're not going to be able to get this thing to work consistently, so we replaced it. But I just kind of kept this hanging around just for whatever reason. But what we're going to do here is, of course, do a bench test of this EGR, both for the position signal delivery and, of course, for, most importantly, that it opens and closes. So that's the easy part. So we need a wiring diagram. So we can see our 5 wires here. We're going to have a gray wire, which is going to be the EGR valve ground, and then we're going to have a red wire, which is the power. Notice here, by the way, I just observed, this is going to be a power side switched EGR. If you remember, on the previous video, the Ford EGR was ground side switched. So on this one, we're going to have a similar problem. When we turn the key to on, actually it's going to be a bigger problem, sort of. When we turn the key to on, I am not going to expect to see 12 volts to the EGR valve connector because that's going to be positive side switch. So we would have to activate the EGR before we would be able to get the 12 volt signal. So that's a thing we're going to run into. I'll talk about that. And one of my subscribers, my friend Eric, who has a channel, South Main Auto Repair, that I've put in my hidden gems list, he's got kind of a little workaround that solved some of the problems with activating the EGR for a do-it-yourselfer that I brought up in the previous series. So Eric, if you're listening, please put a link to that video. I haven't had a chance to look at it, but basically he uses an engine braking technique. Again, it won't work on vehicles that use a VSS, though, or something like that. But for most of you guys, this should help you to be able to activate your EGR signaling, regardless if it's an electronic or activate the solenoid. So Eric, do give me that link in the comments, and I'll put it in the description. So that's our EGR activation right there. We'll have a red wire and the gray for the ground. Putting 12 volts to the EGR valve through those contacts should move the valve all the way open. And then, of course, we've got, let's see here, we've got our EGR position signal wire. We've got a 5 volt reference. That should be on with the key on, so we should be able to do position measurements from the car. And then we've also got the EGR sensor ground. So there's our ground, reference, and signal. That is a TPS for all practical purposes. So I promised to show you a little trick earlier. And one of the things I do whenever I do an engine swap on a used engine, the old engine always comes with wiring harnesses and stuff. And I always like to save the connectors so that when I do testing, if I'm going to do any troubleshooting on a car, if I've got this, it sure makes the troubleshooting a heck of a lot easier. Wouldn't this have been really nice to have for that Ford on the previous video for the solenoid, which was located in a horrific position and I couldn't back probe it? If I had a wiring harness like this available, then I could have, of course, plugged that in and do my back probing testing without even doing back probes. I can just use alligator clips. So a little tip for you, if you do a lot of this stuff, it's kind of handy to have these things around. So let's look at what we got here. It looks like we've got a red wire here, and this I believe is going to be the gray wire. So let's see, let's get these in order, and then these 3 are going to be our sensor wires. So we don't need to worry about those right now. We're going to go ahead and put 12 volts to this. And incidentally, this is the bad solenoid, by the way. Off camera, while I was getting my power probe, I heard a click on this bench here, and it happened to be the solenoid just happened to release, and it is back in place. So let's go ahead and use this, and that way I don't screw around with my known good EGR valve for all this. Not that it'll hurt it, but let's go ahead and put a ground on there, and let's see if we can see how much easier this is with the wires, and then let's see if we can open that. There, see? Oh, and now it's not, well, it's sticking really bad. And now it's back to stuck again. And there it goes. So anyway, we can see that putting 12 volts to this solenoid does move the pintle, but of course it's not very smooth. Let's go ahead and try that on a good EGR valve for comparison. Okay, and we can see there's a lot better response there. And it feels a lot smoother, too. Okay, and it goes without saying, by the way, that you could, of course, do that test on the car with the car running, and of course it would kill the engine just the same as applying vacuum to a vacuum solenoid type EGR would kill the engine while it's idling. So you could do it that way too. So, oops, wrong valve. Let's go ahead and do some tests for the potentiometric measurements here. And wow, I already forgot what we got. Let me look on the wiring diagram again. Okay, so black is my ground, so we'll set that aside for now. Gray is the 5-volt reference, so we can go from the 5-volt reference to the signal wire, and we should get a decrease in resistance. This is exactly how I tested the TPS in the previous video. Although I misspoke on it, I think at some point in that video I said that the decrease in resistance allows more voltage through. That, of course, is incorrect. Decreasing resistance reduces voltage, so I misspoke on that video. But it is hard to not make mistakes when you try to cover everything. But the point is, when I push this pintle in, of course, that should be just like moving a throttle position sensor. We should see a reduction in our ohms here. Let's make sure those show up in the camera. Okay, so I'm going to push the pintle in, and you can see that we get a proportional drop in resistance as I push in and release. So good indication that that potentiometer is working. We can also do this. We can go from the ground to the signal wire like that. And let me get out of the way of the meter. And this should, of course, increase the resistance. Somebody on the TPS video had pointed this test out that I had overlooked. Sorry, I forgot who pointed that out, but it is actually a very good indicator of the ground. And we can see that it does increase as we push in and reduce as we let out. So that completes a bench test on this. Obviously, if the solenoid opens, it's not clogged with carbon, and it responds to the potentiometric tests, then of course we would need to test for signal in the car. So let's go ahead and do the 5-volt signal first and do some other potentiometric tests from the car that we could also do. And then let's look at some scan tool tests that maybe we can do. Okay, so the easiest thing to do, well, actually it won't be easy here, because we still kind of have the same problem as we did the last time, where what we're going to do is let's get voltage here, and of course I want to be extra careful checking my meter to make sure that I wasn't doing an amperage measurement or something before where there's no possibility of jumping this power to ground, because we know that it is coming direct from the PCM, so we do not want to put that direct to ground without a load between. And let's get that there. Okay, and again, I'm double checking to make sure that I don't screw this up. And we know that this is our ground for the solenoid there. Okay, and I need my key to on, so let's go ahead and do that. But of course, we know that we are not going to see voltage yet. So as expected, we of course do not get the 12 volts because it's power side switch. Same problem as the last time. And again, a thing you'll have to figure out, if you do not have a bidirectional scan tool, what you're going to be able to do to turn this EGR valve on, because on most cars you will have to have the car driving. So again, you know, maybe you got to put it up on jack stands. On this car, I'm actually lucky. I do have a better way of doing it. My auto ingenuity will be able to actually control the EGR valve because this is a GM car, so I can actually do that. Actually, I'll demonstrate it pretty soon. But the other thing, again, I'm going to recommend, I will put in the description a link to my friend Eric, who's got his channel South Main Auto Repair, and some viewers from my channel that went over and visited there tell me that he does have a EGR video where he has a pretty slick way of bypassing this problem so that you will be able to activate your EGR through some kind of engine load thing or something. I haven't seen it, but definitely recommend checking that out. But what I'm going to do is go ahead and start the car, and using auto ingenuity, I can actually command the EGR valve to open at whatever percentage I want it to. So let's go ahead and try that. Okay, and I know you won't see what I'm doing, but what I'm going to do is I'm going to command the EGR to open to, let's do 80%. My bet is that's going to kill the engine. And it does, and we see that, let's go ahead and turn that off. We see that we do get our voltage change. All right, and I just realized when the engine stumbled, my meter moved. So we'll go ahead and just try that one more time in case it didn't catch. Let's go ahead and get that EGR on. Engine reacts, voltage reacts. We know we're getting command. All right, I really can't say enough about auto ingenuity. I mean, for just a tenth the cost of a really, really professional scan tool, it's amazing what you can do with this thing. But again, it greatly depends on the type of car you have, and I find it's very friendly with my GM car. So let's go ahead and move on to the potentiometer testing now. All right, and so the first thing we want to do is we're going to want to go to, let's see, I don't know which is which here. Maybe you guys remember, gray was the signal, right? So gray is going to be there. And so let's go here, and I think I got my polarity backwards, but let's go here and see if I get 5 volts. And there's my 5 volt reference signal. So I know I have a good 5 volt reference signal there. That's good. And of course, we could also do the back probe. A way we could test this is, let's see if I want to go ahead and do that. Yeah, why not? It's kind of repetitive from the TPS video, but let's just go ahead and show this because I got some time. Okay, and all I'm doing here is, again, with the key on so that I've got my 5 volt reference signal active. I'm going between signal and ground. I'm doing exactly the same thing that I did with the resistance measurement, except now, of course, we're going to look and see an increase of voltage as I move my pintle. So let's push that pintle, and we see we get a voltage increase there. Exactly the same as when we tested the TPS. As a matter of fact, I'm hoping there might be a EGR position graph I can create on the scan tool. By the way, all the more reason you would want to have an oscilloscope for this so you could graph this and ensure there's no dead spots and that the response is proportionate to position. One day soon I will get that. But let's see here. I think that pretty much should conclude the non-scan tool testing there. So let's look up a scan tool for those of you guys that may have a scan tool. And I'm not sure what PIDs I'll have available, but let's just see what we can play around with. All right, I am opting for auto tap for this because I just happen to know it gives a redonkulous number of parameters for my Trans Am, other than long-term fuel trim bank 2, actually, but that's a whole different story. But let's see what we've got here. So we do have some EGR things here, but not, I want something that shows the position. Here's a position error. This may work. What this does is calculates the percent of difference between the actual position and the desired position. Assuming that there is a desired position of 0 right now, I guess I could use this and then manually move the EGR valve. Sometimes linear EGR works. Here we go. Linear EGR, pintle position. This is what I want. I wonder what these other ones are here. Yeah, those, actually any of these will work. So here's a percentage, and actually let's put that on a graph. And basically what this allows me to do is exactly duplicate the throttle position sensor test that we did in the throttle position sensor understanding and diagnosis video. We're basically going to treat this as a TPS. So let's go ahead and put a graph in there. Okay, so now as I, of course, push in the EGR valve, we should get an exact similar response as we would a TPS. And the nice thing about this too is this also confirms the computer integrity and everything. So all kinds of ways that you can test these things, but ultimately again, without the scan tool, you're going to be considerably more limited. And once again, I'll refer you to one of the main challenges in this series that we've run into that we have not run into in any of the other sensors is the fact that the EGR valve is a valve that is used when the car is moving. Some people had some ideas putting the car up on jack stands and driving the car. That's not a bad idea. Maybe not totally the safest, but I've done that plenty of times. All kinds of things you would have to do, but none of them are quite as easy as this. But anyway, I got a flight to catch. So next time I see you guys, I'll have a car that I'm pretty confident we're going to have to do a EGR diagnosis, and we're just going to zip right through it without the background and just see how quickly we can figure out what's wrong with the car and get a fix in that video. So that should be coming up in a couple weeks. Anyway, thanks again. I hope you found this helpful.